So now let us discuss question number 14.38 from the book of Beer and Johnston on vector mechanics. Now in this question it says that two hemispheres are held together by a cord which maintains a spring under compression and the spring is not attached to the hemispheres. The potential energy of the compressed spring is given to be 120 joule and the assembly has an initial velocity v0 of magnitude 8 meter per second. Knowing that the cord is severed or broken when theta is equal to 30 degree, causing the hemisphere to fly apart, determine the resulting velocities of the hemispheres. Now, firstly, let us write the initial total energy. Okay, so initially the whole system is moving with velocity 8 meter per second. So the kinetic energy will be given by half. M is 2.5 plus 1.5 because the system is moving in totality into 8 squared plus 120 joule is the spring energy initial. Now when the cord is broken, so the final energies will be half M V. So let us call this block as A and this is B. So VAX squared plus VAY squared, okay, plus half M. I'm just writing the components, okay. VBX square plus VBY squared. So this will be equation number 1. Okay. So now what we use the momentum conservation along the x and the y axis. Now initially the whole system is moving along x axis with a velocity 8 meter per second. So this was my energy conservation. So just let me write it here. Now let us conserve the momentum. Momenta conservation. Now along x-axis this will yield initial mass is 8, okay, this initial speed is equal to 2.5 into VAX plus 1.5 into VBY. And along the y-axis there is no initial momentum, so it will simply be 2.5 VAY equals minus 1.5 VBY. So these are the momenta conservation. Now one more condition is given, that the cord breaks at 30 degree. So I am going to utilize that condition also, and I will write VAY over VAX minus 8 equals tan 150 and VBY over VBX minus 8 equals tan of minus 30 degree. Now let me explain how to get these equations. Here the angle is 30 degree. Okay. Finally, we are assuming that the block A is moving here with the final speed of VAX and VAY. So tan theta, you know, VY upon VX. But this cord is broken when the system is already moving with the speed 8 meter per second. So you go relative to this block. Okay, relative to this block the velocity will be VAX minus 8, and similarly for this. So from here you may see that we have got 4 variables and we have reached at 5 equations. Now here comes the most tricky part. These equations, this number 1 looks the most tricky, okay, the most time consuming. So one may think that let us solve these 4 equations for 4 variables and get the answer. But actually these 4 equations are not independent. This condition, okay, because if this is 30 and this is 30, these both are 30, this condition is already absorbed in the fact that there is conservation along y, momentum conservation along y. So if you go and try to solve these equations, this will give you absurd results or even no results. If you write to the proper decimal places, the calculator will simply give the math error. So any one of this coupled with this and this can be solved to get Vax, Vay, Vbx and Vby, and these are the velocities which are required. Thank you.